So in summary, we observe that when there is a local object already fully initialized that we would like to use to pass it as a return object from the function which returns a copy, the copy constructor is invoked, and that's sort of natural. So let's take a look at our copy constructor, right? So this is the version of the copy constructor that we have, and I'll try to place these two side by side like this. And let's draw a little diagram of what we're trying to do here. So we supposedly we construct this object named error string. Of course, this is a local object that belongs to this function select string. So this error string is this object right here, and of course it's a local object. It is destroyed immediately when the function returns from its body back to the caller. Then it could be also that this object right now I initialize it with a statically allocated constant string, but we could have produced something more dynamic. So there is this is not exactly demonstrated here, but there could be a possibility that it would have this pointer to dynamically allocated block of characters. That's what we do in cases such as concatenation, replacements, and other modifications to the string. We always make a copy and we allocate new characters dynamically. So we could have this pointer right here, and then we get to this return statement where we have to manufacture a copy of this object which potentially holds dynamically allocated string, and we have to return back. This is the call right here. So we really have to upon this return, the compiler has no choice but to invoke the copy constructor. So when we essentially we pass a copy of this object to the body of the main function, and so main function gets its own copy right here, and so we use this dynamically allocated string like this. And of course, it would be nice that if we could avoid this unnecessary copy of these characters over to here, because look, in the copy constructor we say that sometimes we have to manufacture a deep copy of another string. So we'd like to avoid this copying. What could we do to improve? Well, C++ allows to detect situations which basically involve passing of fully initialized object from function as a return parameter. Compiler has a way to detect the situation, because we can add something that's called a move constructor. And the idea of the move constructor is this: the size of our string is pretty small. It's like, it's just basically like the size of one integer and one pointer. It's very small. It's actually hosting like a string view object inside of it, but still it's relatively small. So what we can do then is that once we create this local object, I will redraw this again. This is our local object. So instead of making this full deep copy by using new and all this business of updating everything inside of the object that copy of which is being manufactured, so what we can do is basically the idea is that we want to be able to take this dynamic string and simply find a way to point it here. Okay, so just like this. So instead of making this full copy, maybe we could call another version of the constructor, and this constructor in C++ is called Move Constructor. That we could basically make copy of this object, but avoid deep copy of this. Essentially, when this object goes out of scope, because that's a local object, the dynamically allocated memory will remain unchanged. But if we could retain the pointer to this memory in the return object, we should be all set. We should be taken care of with respect to the situation where we're passing the dynamically allocated string over to the caller. So the new type of constructor is called Move Constructor, and the Move Constructor has this signature. So I'm going to my header file, and I am scrolling down to where our constructors were specified. So this is the copy constructor was declared, and now a new constructor is going to be called Move Constructor. Right? So Move Constructor looks like this, and this is the difference. Right? So the copy constructor is expecting its right-hand side, another object used as a prototype to manufacture brand new string. It's treating it as a constant object. But in the case of this function call select string, we would like to be able to steal, basically, steal the resources allocated by local copy. Okay, and we would like to pass it without the need to manufacture a copy of the local object, and I'm talking about the deep copy. All right, so this is called Move Constructor. So let's take a look at its implementation. And again, I'm jumping to the implementation file, and right here, this is something that I'm thinking about. So the Move Constructor is using something that we call R-value reference, which refers to a temporary object. So if you think about this, it's easy to spot that this local string is just about to disappear from the scope of this function. And therefore, its use here is very temporary. Just before it gets destroyed, we're trying to grab its resources, steal them. So first of all, what I do is that I just initialize string view for the selected string being used on the side. And then the pointer also is being used. But then this error string is modified by this Move Constructor, is what that we use to manufacture a return value. So we give it a null pointer. So therefore, when this error string is destroyed at the end of the scope of our select string function, and its destructor is invoked, it will see null pointer, and it will not try to deallocate any resources. However, the new string that the Move Constructor is manufacturing, the one that we return from this function, will retain dynamically allocated string if it happens to have it. So basically, when the above code is executed with this return statement, us providing the Move Constructor, the C++ compiler will call the Move Constructor inside the instead of a copy constructor, which may be important to improve the efficiency of our program. So normally when you have copy constructors, it's a good idea to examine these situations and think about providing a Move Constructor. So let's rebuild the program. Okay, so I'll just close this right now and rebuild what we have. Let's see what kind of error I'm getting here. Yeah, I just forgot to place the semicolon at the end of Move Constructor declaration inside the header file. So let's try this again. And there is something else. Well, I think I just need to get rid of the scope resolution, which I did here by mistake, result of copy and paste. So this would be the Move Constructor. Okay. Alright, so now if I run it, you see that this time when we rebuild this code with the Move Constructor, which is much more efficient than copy constructor because it doesn't care of creation of deep copies. It basically steals everything from another string and gives it to the one that's being constructed. So this time we start using the Move Constructor. And so if we return to our test cases, when we pass two of these strings to the function, and we make a decision to return left or right, of course there is no other option but invoke a copy constructor, right? So these two times right here we invoke a copy constructor. But this is a chance to avoid deep copying, and that spares us from worrying about inefficiency of constructing complex objects, potentially complex objects which are local, and then making copies of them. Because if we provide a Move Constructor, like we did right here, when we provide the Move Constructor, this is really nice because the Move Constructor avoids making that deep copy and gives good efficiency to the program. So I'm now going to preserve this version of the string and just make a copy right here. And rename it as version 5 Move Constructor. So you see that we're making this progression, and you can compare previous version of the string from the start of our experimentation with Java-like string in C++, and this is our latest version where we added the Move Constructor to the project. Okay, so in implementation of my constructor, both of constructors, both copy constructor and the Move Constructor, I've used these tracing statements to indicate the call to copy constructor and Move Constructor. So notice that the tracing statement inside the Move Constructor is using the move word right here. So I'm just going to comment these out so that if we have to bring them back, we can always bring back to do our testing.